I'm Dave Walters. I am head of product for audio at the BBC, and in old money that kind of means chief engineer. I've been doing this a little while. With me on stage today we have...
I'm Steve. I'm the technical officer for the Student Radio Association, and I also work at Global as a broadcast engineer.
I'm Simon Price. I'm head of broadcast engineering for all of Global Radio, so I look after about 25 engineers across the whole of the UK.
And normally what happens, and the people who will be on stage today, we've all worked with or for each other at some point in history. So we're all friends, but ask us questions later. Okay, so what are we trying to build? It's important when you think about radio stations, and if someone asks you to build a studio, what its purpose is going to be. So typically that falls into two different categories, kind of pop music, self-op, or a driven speech radio station. And that starts to drive your thinking around what kind of things you're going to need in it, what kind of space you're going to need, and how it's going to operate. So we're going to talk you through a little bit about some of those choices, but in particular we're going to talk to you right now about the physical construction. What is a studio and how would you build one? So you get to make your choice. You need to do some design, you need to think about your layout a little bit. This is a CAD diagram from probably back about 12 years ago,
something like that, yeah.
When we moved LBC into Leicester Square. And you can see that we're starting to think about the fact that it's some boxes. So it's not just a space in a building, it's some boxes. And those boxes start to drive what you need to do to build and design them. The other thing you need to think about is where in your building, or where your building is, and is it going to be fit for purpose? If you live in a place next to lots of water where flooding happens, that's probably not the best place to put your radio studio or your radio station. It seems so obvious to say, and yet so many radio stations have been built in floodplains or next to canals in basements, Quentin, that challenges happen. So think about that. Other things to think about which are really simple is you're going to have people coming into the building. Is there somewhere to park? Is there public transport to get to? Is there a Tesco's within a 10-minute walk so people can go out and get lunch? And if you're going to have guests coming in, maybe politicians or local celebrities, can they get to you easily or is it going to be hard? Choose where you put your radio station. Okay, so what's the purpose of a studio? In essence, what you're trying to do is manage sound. And the purpose of the studio is to do that in and out. So if you imagine a pop studio, the DJ's got the music on really loud. You want to keep that sound inside the studio because all the people in the office can't concentrate and think when they're being really noisy in the studio. If you're building a speech studio, you want that place to be really quiet because the noisy people in the office, you need to keep that noise out of your studio so that in the studio where the microphones are, they're only picking up what was intended, which is the person that's speaking. So it's all about sound isolation. And sound isolation occurs in three ways: physical, acoustic isolation, and acoustic treatment. So in the physical isolation space, what you need to do is you need to build a soundproof box that's not connected to anything. Sound passes through vibrations in structures. So you've stood next to a train track, right? When the train goes by, you can feel it vibrating. It's the same in studios. People walking up and down outside, jumping up and down, making noises outside. That sound will pass into the studio through physical vibration. So what you need to do is build a box that is not connected in any way to your building. But because unfortunately gravity exists, that's quite hard. So what you need to do is take your floor, diagram on the top left-hand side shows a kind of standard floor slab, and then there's two boxes. There's an inner box and an outer box. The outer box is connected to the floor because it has to be. The inner box then sits on either springs or neoprene pads, so you're reducing the amount of physical contact of your inner studio box to the outer structure of the building. It's really important. It's one of the key ways to manage your sound isolation. So that's physical. You've got to disconnect your physical box from the outside world. And then you need to move into acoustic isolation. Sound generally passes through the air. It's the vibration of molecules caused by my voice or the drum kit or whatever it would be. So the next thing you need to do to make your studio soundproof is stop air getting in and out from the inside to the outside, from the outside to the inside, because you've got to manage it in both directions. So when you're building your studio, you need lots of mass, so typically concrete or lots of plasterboard and heavy weights to stop the physical space vibrating, but in particular to stop air getting in because noise is transferred through air. So if you leave holes in your studio, sound will get in, and that's a problem. So you need to manage that best you can. If you are in a lucky position of contracting some builders at some point to build that studio for you, the builders will not understand that concept. So every day when you're watching them do that job, go in, find the holes, find the bits where they've left some gaps in the plaster, and ask them to go back and fill it. Every single hole needs to be filled. Otherwise, air will move and sound will pass through. And then inside your studio, you've created a soundproof box. But a bit like if you're in the shower in the morning and you're singing, your bathroom will have lots of tiles, probably lots of hard surfaces, so there's lots and lots of sound reflections. And you might think you sound great in the shower. Your friends, partners, family might think differently, but you probably think you sound great, and that's lovely. But in a radio studio, we tend to be looking for a much deader space, a space that's not got all of the reflections, because what we want to do is capture the natural sound of the voice, not necessarily the sound of the room. So if you imagine a church hall, lots of big spaces with really hard surfaces, lots of reflections. You can hear the vibrations and the echoes kind of decaying over time. That's not what you want in your studio. So then what we tend to do is treat the inside of the studio with lots of acoustic absorbing materials. So if you're rich and you're building a really big station, you can go and buy very specific panels. If you can't afford that, typically we then tend to move into the kind of the rock wool, mineral wool area, which absorbs sound quite nicely. And if you really can't afford that, a good budget version, but works really well, big heavy curtains. So lots of soft surfaces to absorb sound. When you're building your studio, you need to think as well about how sound works. So sound is a vibrational wave that comes out of my mouth. As I'm talking to you, it is going to hit this back wall. It's going to reflect back to me. And you get positions and points in your studio where all of those reflections, even though you've treated the surfaces for absorption, all of those reflections will start to build up into kind of hotspots of reflection. So what we try and do is avoid building square rooms. This diagram on the right-hand side, you can see, it looks like a square box, but it isn't. And the purpose of that is kind of a, what would you call that, a parallelogram, trapezoid, not sure. The purpose of that is so that when that sound does reflect off those surfaces, it doesn't reflect perfectly and bounce backwards and forwards. It gets bounced off to one side and starts to dissipate around the room. Finally, you've built your perfect airproof box. You can't see in it, you can't get into it, so that's a bit tricky. You will obviously need to put some doors and windows in. When you have two boxes, when we build our box-in-box studio, the outer box connected to the building, the inner box, which is isolated and floating, you will need two doors, a door for the inside box and a door for the outside box. Again, make them heavy. They probably need to open in opposite directions, otherwise that's going to be slightly challenging. And windows are exactly the same. It's lots of heavy, thick glass. Double glazing tends to work quite well. Double glazing for the outer wall of the studio, double glazing for the inner wall of the studio. And again, this diagram on the right-hand side is showing how those two windows in those two spaces are angled outwards. So particularly, if this was the inside, for example, it says outer wall, let's use this one. If this is the inner studio wall, that window is reflecting the sound down, usually into the carpet. Somewhere it will be absorbed rather than causing reflections around the space. And then you've got to figure out what you're going to do in your studio. Stephen.
Thanks, Dave. So you've got a perfectly isolated room that's got no sound going in or out, but you need to put some people in there. You need to put some tables in there so they can kind of sit around something and use something. So you want to think about what access people need around the furniture. This diagram on the screen is from the same LBC studio we saw a few slides back, different angle of the CAD view. So in this sort of setup, we've got a control room and we've got a main presenting room. So the presenters in here need to be able to see through to the control room over here, and the control room needs to be back to the presenters so they can kind of indicate what's going on. Maybe the presenter is speaking and they want their mics to be turned off or something, so they can kind of wave through the window and say, can you do this? And if the producer needs to say, you need to wrap up, you need to move on, then they'll need to see that as well. If you've got a self-op studio, then you don't necessarily need to be able to see through to other places. You might have a window to the outside world so you can see the weather, because people are really bad at knowing what time of day it is if they're locked in a box. But they don't necessarily need to see anyone else around them. But then you've also got to think about, if you've got guests, how many guests do you want coming in? So in this studio, we've got the presenters over this side so they can see through to the control room. And then we've got the guests sat around because they don't need to see the producers at all. They just need to see the presenters that are asking them questions. Beyond that, you've then got screens as well. So do they need to see a clock so they know what time it is? Do they need to see a play-out machine so they know what's coming up in their music or what jingles are about to play? Any production that's coming up. If If there's a bed, they want to know when it's going to finish. They can not just carry on talking over the end of the bed. Or if they're going to be too short on time. They might need to see TVs. They might want to see like news channels. They can see if something happens. But you can think about where to put all these in such a way that they're kind of not in view, but they are. So this is, I think, do we agree it's a Today programme?
It's the Today programme.
Okay, so this is the Today programme, BBC. So this has got a control room and a presenter in a different room. Up the top here, there's a load of screens, so the producers can see clocks. They've got some indicators there as well, so they can see that they're on air. They can see if the mic's live. If a phone rings, they can see that. If in some studios, if a track's about to end, you'll get a flashing indicator to tell you that. If the fire alarm's gone off. They've also got some TV channels up here, so they can see what's going on in the world. But right in front of them is where they have the mixer, and they can actually control everything. And obviously, through the window, they can see the presenters in there and the guests around the studio as well. I'm just going to go back one. Did I cover everything? Equipment positions. So you also want to think about where you're putting your kit. One of the sessions later on is going to talk about CTAs and racks rooms. So are you going to put your kit in the studio? Are you going to put it out the studio? There's these magical devices called KVMs, which take all of your video, your audio, and your keyboard and mouse control and put them in a different room to where the PC actually is. So you can have all of your noisy kit not in the studio, and just what you need is in there. And also all your mics and everything, which I think is covered later on.
Thanks, Steve. So, now that you've created your perfectly sealed room that Dave has expertly designed for you, and also put all of your furniture that Steve sorted out, you're going to find your presenters not really going to last very long in there without some kind of air supply. People generally don't tend to last too long in that environment. It's also going to get pretty smelly in there if there's someone sitting in there 24 hours a day in your radio studio. So after you've built your perfect box, I'm going to tell you that you need to make a great big hole in the side of it. To make a nice environment, you're going to need to do two things. You're going to need to bring some fresh air in, and you're also going to need to do something with cooling. Even in this day and age of digital mixers and LED lighting and LCD screens, it all generates a fair bit of heat. And also a person gives off about 100 watts of heat as well. So you've got to do something to get rid of all that heat that's built up in your studio. So firstly, the fresh air intake, kind of a little bit like the studio that Dave was designing. You have a fan which pushes some outside air. The aim is to get rid of all the noise and stuff that's outside your studio that you don't want getting into your room. And basically, what this is showing is that the fan blows the outside air in, it directs it through a series of baffles. The idea is all of these are absorbent, so you're trying to get rid of as much of the noise as absolutely possible. And out the end of it, you'll get some fresh air that will help your presenter breathe a little bit better and will also be fairly quiet. Also, you're going to need to do, obviously, the cooling. So there's two ways of doing it. You can either have a ducted system. Both of these have different benefits and not. So if you have a ducted system, generally it's quieter in the studio. The other thing you can do is if you're doing pop music or something where you're not too bothered about a little bit of studio noise, you might find it's cheaper to use like an office cassette type unit, which is the one over on the right hand side. Next, you need to power all of your kit. This isn't really the right way to do it. You'll end up in an awful mess. All this kit you've got to keep on and power 24 hours a day. It's messy, it's horrible, and will probably end up burning down your nice studio that you've designed. The proper way to do it is with these units. Mains distribution units, or MDUs, are what we've shown on the right-hand side of the screen. This allows you to safely keep all your kits powered up. You can power sort of up to about 24 items of kit out of one of these devices. You can get different designs, some that mount in a rack, some that you can mount in your studio furniture, and these will normally connect to either some 13-amp sockets, just for you plugging in normal bits of kit, or plug into IEC leads. Don't call them kettle leads. Engineers don't like them being called kettle leads, which are then shown over there on the right-hand side. The other thing that these MDUs sometimes have is power switches. Generally, power switches on some of these things aren't a good thing. Generally, you mount them in the woodwork, and what you'll find is as the presenter turns their chair around, they'll knock into the power switch and turn themselves off. That's caused us several call-outs over the years of having to go into the studio in the middle of the night and go, oh, you've obviously hit this. So we tend to put ones without power switches in some of the studio furniture. What you should probably have in your studio as well, what you should definitely have in your studio, is a master power switch. So like the item up at the top left, locate this somewhere that's kind of accessible should you need to get to it in an emergency, but not too accessible, so that you kick it on the way into the studio, which we've also done. So that's a master power switch for the building, for the room. The other things you can invest in is a UPS. So if you have a short power cut, all your computers are going to reset. Computers, as we know, take 3 or 4 minutes to reboot on a good day. So have a UPS that will keep your station running and on air. You can get different sizes depending on how long you want it to last or what you're trying to power off of it. And also generators. Generators will obviously keep your building running. If you know you're going to have a power cut for a couple of hours, if you're commercial station, you're making money, you need to play the adverts, you need to keep your power running at all times. So once again, generators can be sized depending on how many studios you've got, how much other kit and stuff you need to run. So doing some of the things that we've talked about will help you avoid some of the mistakes that we've probably all made when we've designed studios over the year. So hopefully some of this knowledge has been useful to you. What you can also do, if you want to do a shortcut, this is a video of a prefab studio that we bought a few weeks ago. This shows you how to build a studio in under an hour. So this arrives on a pallet. This is just a simple news booth that we had to build in a hurry. It comes in sections that you literally just slot together like giant Lego, and will eventually piece together.
Is that a stand-up news booth?
It's a stand-up. It is a very small news booth, but it served the purpose, and that's all you need. Any questions?
So whistle-top tour there. We almost certainly glossed over some really basic things, and you guys need to tell us what that was, so we can tell you what they were, and then you have the complete picture. Do we have any questions?
I see more and more these days, a lot of studios have a lot of glass walls. Obviously that would cause a lot of reflections. How do you get around having a lot of glass in a studio?
So the BBC for the last 6 or 7 years has been building quite a lot of very specific glass wall studios, and they're a compromise. And I think the kind of philosophy that we take is that while they're certainly cheaper and they're quicker to assemble because it is just big sheets of glass, that it's not perfect for every situation. So you need to choose where it's appropriate. But in particular, how do you manage that? It's all about angling of the glass. So bend all your glass in different directions. It's all about the parallel walls that we looked at, point it in different ways. But once you've done that and better manage that to the best of your ability, you need to add absorption. So you could put a sofa in a corner. We quite often hang huge acoustic pillows, for want of a better phrase, off the back walls to do some of that absorption. So it's a compromise, but in certain cases it's appropriate.
Using the ceilings is a good way to get rid of a lot of the reverberation as well in the room.
And if you have the time, once you've built it, you could then go in and work out where the good acoustic spots are and do your mic placement around that as well.
Again, it depends what you're using the studio for as well, isn't it? If you're recording chamber music, because I think you wouldn't do that in a glass studio.
Correct. Hi, here comes the microphone.
I once watched a programme on Open University which talked about some sort of room where they managed to they had sort of triangular spaces and all sorts of different things on it to try and make the volume, the ambient noise in there as minimal as possible. And they ended up with the machine reading negative readings. Is it possible to over-quiet a room? Is it possible to go too far with soundproofing and sort of cause almost problems by doing it, making it sound too dead?
So it depends what you want to achieve, but yes, it's a thing. So in BBC drama studios, we apply a standard kind of, so you'd end up with a studio space that's probably about the size of the room that you're in right now. So we then need to manage the acoustic in that room, and we tend to aim for an RT measure, a reverb time measure, of about half a second. That's kind of your kind of target kind of thing. But in that drama studio, we want to recreate many different experiences. So one day they might be, pretending they're chatting in a small bedroom, or they might claim to be in an open field. So one of the techniques that we use in the corner of the room is to build almost like a snail shell kind of corridor that goes round and round and round in circles until you end up in a point in the middle. If you acoustically treat that entire snail shell corridor, you get to a point where if your microphone is on the outside of that, you could be having a conversation saying, I'm going to go outside, and you keep talking as you're walking down this snail shell. And the absorption creates the illusion of you disappearing off into a field. You disappear into a dead zone, basically. So you can kind of achieve that, but you normally try and design it rather than having it happen by accident.
So just what you were saying about like the glass walls and stuff like that, depending on what the use of the studio is, surely with podcasts with limited time frames to record a certain amount, or if you're trying to create really engaging discussion, you want to minimize distractions from the outside world. So do you think maybe it's going to come back around to just having one small kind of window, because you've got 3 guests in there, you want to create like really amazing reactive conversation, but you don't want them to be like, oh, there's 14 people walking past the window.
So I think it's different spaces. I'm answering all the questions here.
Yeah, no, it's fine.
Carry on.
It's different spaces for different experiences. So you're entirely right. And we're starting to build studios at the BBC now that don't look like typical studios. They look or feel a bit more like a front room. So it's a pair of sofas in a kind of a V shape, so that people can just sit and kind of have a chat across the thing, and they're not looking at a whole bunch of playout computers or screens or faders, because that's not a natural environment for people who are not naturally broadcasters to kind of have a conversation in. So it's appropriate things for appropriate uses, I guess.
And we've actually been sealing windows up in studios that we've been refitting recently, just because of the filming aspect, to try and keep some of the natural light out, just for the colour balances and things like that. So.
Does your studio still have that big sliding wall?
It does have the
window or massive video screen.
Radio presenters like to see what the weather's like outside, so they've got something
Yeah.
to talk about. People that film it hate the mix of
Most
light
people
sources.
can't afford a screen about this side to slide across their studio on demand, but when you can, it's a great
Yeah,
solution.
exactly. It's not broken yet.
What do you do when you don't have the money to build a nice studio that's mounted on springs and you're kind of just given what you've got?
Do the best you can.
Yeah, curtains. Lots of soft furnishings, heavy fabric does a lot of the sound absorption. And again, it kind of depends what you're doing. So certainly in the podcast world, we start to see a lot now of microphones that come with a built-in acoustic shield that wraps around the back of the microphone. So rather than treating the entire room, you can it's not perfect, but it does a reasonable job for about 50 quid. It kind of treats the immediate space where your microphone and your mouth will be, and you get reasonable results from that.
Carpet tiles are really good.
Yeah.
Get those really cheap carpet tiles that normally you have on the floor and look really old and horrible. Stick them up on the wall, and you've got absorption on the wall in a really cheap way.
And also using suspension mounts for the microphones as well, is a good way of getting rid of lots of noise as well that gets picked up through the furniture and things like that.
It's a world of diminishing returns, right? So if the only space you can record in is next to Heathrow runway 2, then you're probably on a loser. Whereas if you've got a shed at the bottom of the garden in a reasonably quiet residential space, cheap and cheerful will probably do a reasonably good job.
There's a lot of voiceover artists that have just recorded in their spare room with curtains and stuff on the wall. And
So we get calls all the time from people going, I need to do an ISDN down the line or whatever, and I need to do it from home. And it's like, okay, go to the cupboard under the stairs, put a duvet over your head, and crack on, and it's effective.
Yeah.
We have 38 seconds left before we're out of time.
What is an ICM?
ISDN, a very old school BT delivered digital phone line that allows you to connect, in our case, a radio audio from one place to another over a digital phone line. And it's about to be discontinued, which is a huge issue for the radio industry because we have thousands of these in the field. It's the kind of little box that you'd see at a sports report, at a football match where the guy's got the little lip mic and he's talking into a little brown box, magically over the phone line connects to the radio station, football gets broadcast.